Hello, my dear students. I know. Board exams are just around the corner, and the tension is building. But please, don't you worry one bit. Today, we're going to tackle a chapter that I know many of you find a little tricky, solutions. And I promise you, by the end of this quick session, you're going to feel so much more confident.
So, are the board exams really giving you that much tension? Alright, don't worry, beta. Let's just master this solutions chapter together, and we'll do it in just a few minutes. I'm gonna make it so simple, you'll wonder why you ever worried in the first place. Are you ready? Chalo, let's begin.
Okay, so let's start right from the very beginning. What is a solution, really? Before we even look at the textbook definitions, let's just think about it in a really simple way. Well, a solution is just a homogeneous mixture of two or more things. Now that word homogeneous, it just means it's mixed up so perfectly that it's the same all the way through. You can't see the different parts. And the best, most delicious example, a perfect glass of Nimbu Pani. Think about it. When it's made just right, every single sip tastes exactly the same. Just as sweet, just as salty, just as lemony. That's a solution. Now you should know that every solution has two main parts. The first one is called the solute. The solute is simply the stuff that's present in the smaller amount. It's the thing that gets dissolved. So in our Nimbu Pani, what are we adding just a little bit of? The sugar and the salt, right? So they are our solutes. Simple, henna. And if the solute is what gets dissolved, then the solvent is the thing that does the dissolving. It's the component that's present in the largest quantity. So back to our Nimbu Pani, what's the main ingredient that we have the most of? Of course, it's the water. The water dissolves everything, so water is our solvent. Solute plus solvent, that gives you the solution. So easy. Okay, so now that the basics are crystal clear, let's build on that. How do we actually measure the strength of a solution? You know, it's really just a fancy way of asking, hey, how much solute do we actually put into our solvent? This whole idea is what we call concentration. Now, one of the most common ways we measure this is with something called mass percentage. Please don't be scared by the name. It's very logical. It's just the mass of one part divided by the total mass of the whole solution, and then you just multiply it by 100 to get a percentage. It's that simple part over whole calculation you've been doing for years. All right, let's put this into practice with a typical exam problem. Calculate the mole fraction of ethylene glycol in a solution containing 20% of it by mass. Okay, so the question uses two terms, 20% by mass, which we just talked about, and mole fraction. Mole fraction is just another way to measure concentration. It's simply the ratio of moles of one component to the total moles of everything in the solution. Let's see how we can solve this, step by step. Okay, let's break this down. Look at step 1. Whenever you see a percentage problem like this, the easiest trick in the book is to just assume you have 100 grams of the solution. Why 100? Because it makes the math so simple. If the solution is 20% ethylene glycol, that means in our 100-gram sample, we have exactly 20 grams of ethylene glycol. And the rest? Well, it must be water, so 100 minus 20 gives us 80 grams of water. Easy. Now for step 2. We need to find the moles for each part. Remember the formula? Moles equals mass divided by molar mass. So for ethylene glycol, that's 20 grams divided by its molar mass, 62, which gives us 0.322 moles. And for water, it's 80 grams divided by its molar mass, 18, which is 4.444 moles. See? Now we have all the pieces we need. Fantastic! Now for a really cool and interesting topic. Have you ever picked up a bottle of Coke or Pepsi and wondered, what exactly makes it so fizzy? Well, the answer is a very important concept in chemistry called Henry's Law. Let's check it out.
Okay, I know Henry's Law sounds a bit complicated when you read it, but the idea behind it is incredibly simple. It just says that the amount of gas you can dissolve in a liquid, well, it depends directly on the pressure of that gas. So in simple words, more pressure means more gas dissolves, less pressure, less gas dissolves. That's it.
This picture here shows Henry's Law perfectly. You see, inside a sealed soda bottle, they pump in gas at a very high pressure. This high pressure forces a whole lot of carbon dioxide gas to dissolve into the liquid. But the moment you twist that cap, psst, you release all that pressure, and suddenly the liquid can't hold on to all that gas anymore, so it escapes as bubbles, and that is your fizz. So just remember, more pressure, more fizz.
And you know, this isn't just about soft drinks. Henry's Law has some very serious, real-world consequences. For scuba divers, as they go deep underwater, the pressure increases, causing more nitrogen gas to dissolve in their blood. If they come up to the surface too fast, that pressure drops and the nitrogen forms painful, dangerous bubbles in their blood, a condition called the bends. It's the same idea for mountain climbers at high altitudes. The air pressure is low, so less oxygen dissolves in their blood, which can lead to a condition called anoxia. It's the same principle at work everywhere.
Okay, let's move on to our next topic, and trust me, it's another fascinating one. We are going to talk about the magic of osmosis, and we're going to see how water can actually move all by itself from one place to another. This slide right here explains the entire concept. Just imagine a container that's split in the middle by a special wall. We call it a semi-permeable membrane. You can think of it like a security guard that only lets the small water molecules pass through, but it blocks the bigger solute particles, like salt. Now, on one side, we have pure water, and on the other, a salt solution. Nature always wants to create a balance, so the water molecules will automatically start flowing from the side where there are more of them, the pure side, over to the side where there are fewer, the solution side. This natural movement is osmosis. So the official definition is right here. Osmosis is the spontaneous flow of solvent molecules, like our water, through one of these special membranes moving from a pure solvent towards a solution. The most important thing to remember is the solvent always flows from a place of lower solute concentration to a place of higher solute concentration.
And believe me, you see osmosis happening all around you. When your mom makes a char, she puts raw mangoes in a lot of salt, right? That salt creates a high concentration outside the mango, so water gets pulled out of the mango cells by osmosis, and that's what helps preserve it. Your RO water purifier at home actually uses the opposite process, called reverse osmosis. And it's also why doctors tell us not to eat too much salt. The extra salt in your body can pull water into your tissues, causing swelling or edema. It's chemistry in action.
All right, you have understood these concepts brilliantly so far. I'm very proud. Now it's time to practice a real exam-style question. Don't be nervous at all. Just read it carefully. I know you can do this. Okay, here's the question. If N2 gas is bubbled through water at 293 K, how many millimoles of N2 would dissolve in 1 liter of water? Now look what they give you, the partial pressure of nitrogen and the Henry's law constant, Kh. As soon as you see that, you should think, aha, this is a direct application of Henry's law. Let's apply that formula.
Okay, let's just walk through this. Step 1 is to use our Henry's law formula to find the mole fraction, which we call X. And the formula is X equals partial pressure divided by the Henry's constant. For step 2, we just put in the numbers from the question. So that's 0.987 divided by 76,480, which gives us a very small mole fraction. Now for the final step. We use that mole fraction to find the actual number of moles of nitrogen. Since the solution is almost all water, we can make a simple approximation and multiply our tiny mole fraction by the number of moles in 1 liter of water, which is about 55.5.
And when you do that calculation, the final answer you get is 0.716 millimoles. See, it wasn't so tough when you just go step by step, right? You used the formula, you plugged in the numbers, and you got the right answer. Shabash, well done. I'm very proud of you.
And that's really it. We've covered the basics of what a solution is, we've talked about concentration, Henry's law, and osmosis, and we even solved a couple of typical exam problems. It's actually quite simple when you break it down, isn't it? Now, just imagine, what if we could make every single chapter in chemistry feel this easy? Keep that confidence, my dear students, keep revising, and you are going to do wonderfully in your exams. All the very best.